Elephants, camels, rabbits, goats, and humans have eyelashes, but why? Inspired by a study, we wanted to explore this.
Meet Eileen and her brother will.i.am. They're our eye models. We visualized airflow over them using shadography.
It's already been used to show air around a speeding bullet. All you need is a light source, air, and a dark room. Let's show flow around will.i.am first. And next, flow around Eileen.
Side by side, we can see some clear differences. Take a look. To understand what's going on, we need some key concepts, like what's a boundary layer? Whenever continuous fluid flow hits a surface, a region develops where there's a velocity gradient. This region is the boundary layer. As a result of the no-slip condition at a surface, and because fluid layers cannot be discontinuous, velocity gradually increases as height away from the surface increases. The existence of this boundary layer separates the flow into two regimes, one of which is the boundary layer, in which viscous forces are significant. Now, what is shear stress?
It's a force, not just any force, but a force that arises from the presence of velocity gradients and acts parallel to the surface. Shear stress, represented by tau, is proportional to the maximum velocity within the boundary layer, du, divided by the height of the boundary layer, dy. The proportionality constant is mu, which is the dynamic viscosity. In our case, this surface is actually the surface of the eye.
We visualized all this in COMSOL, which solves Navier-Stokes and continuity equations. What did we see in our model? First, it was obvious that there was lower air velocity at the surface of the eye when eyelashes were present, just based on a qualitative look at the streamlines and velocity vectors. Compared to the no-lash case, the streamlines began to diverge farther from the surface of the eye with lashes.
We're able to quantify this difference by plotting the magnitude of the air velocity in the x direction versus the height away from the eye surface. For will.i.am, we saw that the height of the boundary layer was at 3 millimeters. However, for Eileen, we saw that the boundary layer height occurred about 3 times as far away. Thus, the eyelashes were shown to increase the boundary layer height, reducing the amount of shear stress on the eye.
This is exactly what we saw experimentally. Airflow disturbance began farther from Eileen's eye surface than Will's, so there was less shear stress on her eye. We also noticed that the air circulated as it approached Eileen. In COMSOL, we saw that vortices do indeed appear around the eyelashes, perhaps adding additional protection by circulating particles out away from the eye. In the future, we can test this hypothesis. So eyelashes reduce shear stress, reduce evaporation, and protect your eyes.